itself is a very great inspiration person for the others. So,
Hello.
Naveen yesterday told
Hello,
me,
hello.
can you inspire the students?
Vinod, sir.
So, for the students, only four things, in my opinion, if you these four things you can
Hello.
keep in mind, you will never fail in the any of the your career goals. Dedication, hard work, passion, and consistency. So if these four words, if you follow in life, you will never going to fail. If anything is going to, miss from the all four words, you cannot go the success in your life. So again, I can repeat: dedication, hard work, passion, and consistency. So anyone is missing, you miss the goal. And every student life, you try to make the goal like you and your goal. No third person will be doing that.
Okay, what's
Then
up?
only you can achieve the goal. If it is something between them,
Hello?
then you cannot achieve the goal. So, on most technical part, I will discuss about my research.
కొంచెం బేసిక్
during
ఉండేది
the,
కావాలి, హైట్ కావాలి,
my
టేబుల్
talk.
ఎదురు సెట్ చేయి.
So basically, I will focus on how you can do the subject to help science as a societal tool to help the society. Then I will talk about the another topic like how you can serve the industry. So how you can choose some topic for the industrial application. And I mean also just like to one word to include like I said the societal application. So very big problem in the today's life is like the counterfeiting in the medicine, currency, passports. So I will give you some glimpse how we can protect our products. So how we can save the society from them. Similarly, for the industrial application, I will discuss about something about the car headlights, how change the life, and how the new car headlights laser base is going to come in emerging time. And third, some basic science I will discuss like the quantum or 4D materials. So trying to student to give a glimpse to by this conference to how and why we can say the material can be smart. So why we are saying the word is smart, and very good topic compare the the theme of the conference because smart material and applications. The mean of that you can choose something. There is some use like you done some discovery, there is some innovation, not only invention. Invention means you can just limit the lab, but it cannot be going to exploit. But if you are doing the innovation, it can be utilized for the publicly. So, by these words, and because you have really many eminent best speakers are there, so they will more motivate. And main motivation, I forget to mention, Professor Sudhir is here also from this place, and I hope he has the good interaction with the college always, and they can we can push the the level of the science here because we forget always to go to big places like IIT, ICSR, ISC, and we forget to go to places where really our stones are, gemstones are there, but we are forget them to motivate. So I will respect to if they can contribute something from his own words and trying to some even commitment like I can commit to you. Any student from the MSc from here, they want to do the national lab for the some project 6 months. So I want to especially to support the rural students. To I will give my own money for the training 6 months, and they can come there and they can do the 6 months project. And another example is like my director is also from this place. Only yesterday I know. So a lot of persons already you have these diamonds around you, so you have to find out and you get inspiration and do your path to where you want to go the success. So thank you very much.
థ్యాంక్ యూ విపిన్ కుమార్ గుప్తా గారు. చూసారా, మీరు ఒకటి గమనించారా, వీళ్ళందరూ ఎవ్వరూ కూడా దే హ్యావ్ కమ్ ఆల్ ద వే ఆన్ ఫ్లైట్స్ without charging even a single rupee from the college. ఎందుకోసం వస్తున్నారు ఆలోచించండి. ప్రతిదీ వాళ్ళ సెల్ఫిష్ ఏదో ఉంటుందని ఆలోచించకండి. మీకోసం రూరల్ ఏరియాలో ఉన్న పిల్లలతో కనెక్ట్ కావాలి, వాళ్ళతో మాట్లాడాలి, ఇంటరాక్ట్ అవ్వాలి. అందుకోసం I had the opportunity to speak to Dr. Sudhir Kumar Garu a few days ago, and he is a very good speaker, and I had a good interaction with him. So I wish Dr. Sudhir Garu to speak a few words to the gathering. Thank you, sir.
హలో, నేను సుధీర్ కుమార్ వెంకటేని. నేను తెలుగులో మాట్లాడతాను. నేను ఆంధ్ర యూనివర్సిటీ ఎంఎస్సీలో చేసేటప్పుడు చాలా మంది నా ఫ్రెండ్స్ ఈస్ట్ గోదావరి నుంచి వచ్చారు. దే ఆర్ వన్ ఆఫ్ ద బ్రైటెస్ట్ పీపుల్ ఐ హావ్ సీన్ ఇన్ మై లైఫ్. They are one of the brightest people, I can tell you that. So, Godavari districts లో పుట్టిన వాళ్ళు, పెరిగిన వాళ్ళు, చదువుకుంటున్న వాళ్ళు, they are very bright. అది బై అజంప్షన్, అక్కడ పుట్టినందుకు ఆ నీళ్లకు నాకు తెలియదు ఓకే. బట్ మనం ఇంకా ఎదగాలి, అది మెయిన్ థింగ్. యూ హ్యావ్ ఎ వెరీ విజనరీ ప్రిన్సిపల్. హీ ఈస్ ఎక్స్ట్రీమ్లీ విజనరీ.
Sir, excuse me one minute. Dear students, do you know me? He is a great person. He is from Indian Institute of Science, Bangalore, the prestigious, most prestigious institute. Please, thank you.
Okay, you have a very visionary principal. అండ్ నేను ఇప్పుడే ఒక కాన్ఫరెన్స్ ఆర్గనైజ్ చేసి వస్తున్నాను, అందుకోసం లేట్గా రావాల్సి వచ్చింది. నిన్న కూడా సైన్ చేస్తున్నారు బిల్స్. సో ఇట్స్ వెరీ హార్డ్ టు ఆర్గనైజ్ ఎ కాన్ఫరెన్స్. వెరీ వెరీ హార్డ్. అది మంత్స్ ముందర ప్లానింగ్ చేయాలి. ఆ తర్వాత అది ఆ కాన్ఫరెన్స్ అయిపోయిన తర్వాత కూడా చాలా రోజుల వరకు ఆ పని జరుగుతూ ఉంటుంది. అండ్ హీ ఈస్ అమేజింగ్. హీ అండ్ శ్రీనివాసరావు గారు, దే ఆర్ రియల్లీ అమేజింగ్. యూ షుడ్ బి వెరీ వెరీ లక్కీ టు హ్యావ్ ఇట్ హియర్. సో జస్ట్ ఎక్స్ప్లాయిట్ దెమ్. వాళ్ళ విషయాన్ని ఫాలో అవ్వండి. సో వాళ్ళు చెప్పింది వినండి. యూ విల్ బి ఫైన్ ఇన్ యువర్ లైఫ్. ఐ థింక్ దట్స్ ఆల్ యాక్చువల్లీ. ఇంకోటి నేను గమనించాను, దెర్ ఆర్ లాట్ ఆఫ్ గర్ల్ స్టూడెంట్స్ ఇన్ దిస్ కాలేజ్. దట్ ఈస్ వెరీ వెరీ గుడ్. యునో, at undergraduate level we have a lot of girl students, but the number of students will fall off directly by the time they finish their masters or by the time they do PhD or something. Number of students, girl students, చాలా చాలా తగ్గిపోతున్నారు. దానికోసం ఏం చేస్తున్నాం అంటే ఇప్పుడు స్పెషల్ ప్రోగ్రామ్స్ చేస్తున్నాం ఫర్ ఉమెన్ ఇన్ స్టెమ్, ఉమెన్ ఇన్ సైన్స్ అని. ఓకే, సో ఇఫ్ యూ ఆర్ ఇంట్రెస్టెడ్ ఇన్ సైన్స్, there are opportunities for girls. Okay, there are special programs. TIFR is organizing special summer programs only for girls. Okay, so there are we organize special coaching programs for girls who are attending interviews to our any of MSc or MS or BS, MS, PhD, integrated PhD అంటాం మేము, లేకపోతే PhD programs కానీ. We organize separate coaching and give indications. కొన్నిసార్లు అయితే క్వశ్చన్ పేపర్ కూడా చెప్పేస్తాం మేము, ఎందుకంటే we want the women to come. Okay, we want to fill our labs, our classrooms, everything with women. Okay, so take that opportunity. అలాగని మగవాళ్ళు మానేయద్దని చెప్పట్లేదు, వాళ్ళు కూడా చదువుకోండి. ఓకే, కానీ నేను అబ్జర్వ్ చేసింది ఇక్కడ చాలా మంది ఉన్నారు, అందుకోసం నేను చెప్తున్నాను. So take those opportunities, and if you, I'll share my email ID with Professor Srinivasarao garu and the principal. If you have any questions, send me an email. I'll help you whatever I can. Okay, I can guide whatever I can. If you are interested in science, please do well. Okay, there are no dearth of opportunities. Thank you. Yeah.
Thank you, sir. Thank you very much. And I request on behalf of the students, ఐ రిక్వెస్ట్ డాక్టర్ సుధీర్ గారు, మీరు ఒకటి గమనించారా, ఈ డయాస్ మీద ఉన్న వాళ్ళందరి పేరు ముందు డాక్టర్ అను, అదేనమాట దాని లెవెల్. ఐ రిక్వెస్ట్ డాక్టర్ సుధీర్ గారు టు ఎక్స్ప్లోర్ ఇఫ్ పాసిబుల్ టు ట్రైన్ 3 or 4 of our students in long-term internship, that is for 6 months in 6th semester. We do have the provision. If it is possible for IISC, such a great organization, I don't know, but I request you to permit our students to be associated with IISC, sir. Thank you very much. Now I request Naveen Kumar Garu, who has come all the way from South Korea to speak to you.
Students, quiet please. This is the last speech, right? It follows by a small felicitation. Please cooperate.
Good morning to all of you. At first, I'd like to thank Professor J. Hemlatavan and Professor Bipin Kumar Gupta from National Physical Lab, Delhi, and Vishnu Prashant sir, Professor Vishnu Prashant from Mohan Babu University, and the other faculty members who I invited. Thank you very much indeed to gathering over here, and only on one request over a telephone they came over here to empower your knowledge in this esteemed institution. Thank you very much indeed for your kind cooperation on this matter. And I request the faculty members comes from rural areas, from various degree colleges and some other institutions to utilize successful utilization of this auspicious occasion on the material science importance and some various factors to enrich the minds of the students for brighter their lives. And also I thank Professor K. Srinivas Ragaru who invited me to this great opportunity to involve actively in this material science conference. Thanks a lot. And I have seen this area and the infrastructure and the students' discipline and all the things. I am very happy to be here and delighted to. Thank you very much indeed for your kind support.
ఇలాంటి ఏ కాన్ఫరెన్స్ ఆర్గనైజ్ చేయాలన్నా ఖచ్చితంగా అందరు సపోర్ట్ కావాలి. మన మండపేటలో ఉన్న పెద్దవాళ్ళందరికీ ఈ కాన్ఫరెన్స్ కి ఓఎన్జీసీ వాళ్ళతో పాటు మన ఊర్లో ఉన్న వాళ్ళు ముందుకొచ్చి మీకోసం ఏది చేసినా మీకోసమే, మీరు దాన్ని అర్థం చేసుకోండి. భోజనాలు, బ్యాగులు, బుక్ పబ్లికేషన్ అన్నింటికి కూడా కొంత ఫైనాన్షియల్ అసిస్టెన్స్ ఇచ్చారు, వాళ్ళు డబ్బులు ఇచ్చారు. మేమున్నాం, మీరు చేయండి, మేము బ్యాగ్స్ ఇస్తాం, మేము ఫుడ్ ఇస్తాం, మీరు చెయ్యండి, మీకేం భయం లేదు అని వాళ్ళందరూ మాతో నిలబడబట్టే మేము చేయగలుగుతాం. సో ఇట్ ఈస్ అవర్ రెస్పాన్సిబిలిటీ, the college administration and the college students, it is our responsibility to facilitate them, మరి వాళ్ళకి సన్మానం చేయాలిగా మనం. సో మనం మన స్పాన్సర్స్ ని వాళ్ళందరినీ కూడా సన్మానం చేసుకుని వాళ్ళు గౌరవించాలి. మీరందరూ కూడా యూ షుడ్ బి విట్నెస్ టు సచ్ ఎ గ్రేట్ ఈవెంట్.
So now I request, we have a small felicitation to our collaborator sponsors. They have supported a lot. So firstly I request Sri Remalpudi Narayan Rao Chaudhary garu from Kalyani Restaurant, Order of Kalyani Restaurant, to come and to receive a small presentation. చేయాలంటే స్వామిరా Bags. Fix it. Thank you so much. Now I request Sri Inupakola Ganesh Garu, Managing Director, Chairman of Vijnan Institutions. Thank you so much, Ganesh Garu, Chaudhary Garu, and Sri Pippali Chakravarti Swami. He also kindly supported. Chakravarti. Thank you so much, Chakravarti Garu. And now I request Sairam from SK Travels. He also supported. He kindly given all the transport required for this conference. Thank you so much, Sairam. It is an honor, please. Ranga Garu, please come. Please. Please, college. Bags and the bags. Thank you so much, Sairam. Now I request Sanka Srinivasa Ranga Garu. Sanka Srinivasa Ranga Garu, he kindly supported us last minute. We approached him and kindly supported. Has given 20,000 worth this mementos. Please come under the sir. Please to have a master stage. Thank you so much, and Ranga Garu. Thank you so much. Any more? Am I missing? Please. So I request our Vice Principal Anand Garu to propose vote of thanks. No, excuse me, sir. I want to felicitate the dignitaries also, speakers also. Please. Okay. Just excuse me. So I request Hamlata Madam to receive a small felicitation. I request Sudharani Madam, Sudharani Madam. Swami, please come on to the Madam ki shawl level. Madam, please. Now I request Dr. Bipin Kumar Gupta sir to receive our felicitation. Thank you so much, sir. He has come all the way from New Delhi. He is the principal chief scientist, National Physical Laboratory. Madam is also, Hamlata madam, I missed her 2 times. I called her 2 times. The third time, I can have visit here. So I am heartfully thankful to all of them. Hamlata madam is also very busy. So kindly accepted our request. Next, I request Dr. Neelam Kumar, madam. Please. Madam, ladies. Thank you so much, madam. Hello, madam. She also came all the way from New Delhi. We didn't pay any single paisa to her. She spent more than 15,000 rupees to come here from her pocket. Thank you so much, sir. And next, I request, sir, Dr. Sudhir Kumar, sir, please, to receive our small present. For Sudhir sir also, he came all the way from Bangalore. We didn't pay any single paisa to him. So please, clap, please. Right. Thank you so much, sir. Once again, Dr. Sudhir Kumar, sir. Now I request Dr. Vishnu Prasad, sir, son-in-law of my guru and the professor of physics, Mohan Babu University, Tirupati, to receive small presentation. Thank you so much, sir. And now I request Dr. Naveen Kumar and Bhargav. They have come all the way from South Korea. Okay. Thank you so much. Akil Bhargav. He is also came from that South Korea. Just today morning they landed here. Naveen, what is it? Thank you, Bhargav, sir. Thank you very much. And one more, Dr. Naveen. Dr. Naveen is also a good friend of mine. We are the co-scholars from our guru. So, Dr. Naveen, please have this presentation. No, please take it. So, behind the screen, the conference ki anta, Naveen Kumar, Dr. Naveen Kumar. Thank you so much. Thank you, sir. Thank you so much, my dear friends. At last, I request our Vice Principal, Dr. Anandra Garu, to propose vote of thanks. Please, sir. Please be seated.
Good morning to Honorable Chief Guest and Guest of Honors and respected speakers and distinguished participants and dear colleagues and students. As we come to the end of this inaugural function, I am honored to extend our heartfelt thanks on behalf of Government Degree College, Mandapeta. Firstly, we express our sincere gratitude to our chief guest, Sri Vegurula Jogeshwarrao Garu, Honorable MLA, Mandapeta Constitution, for gracing us with your presence and delivering and your inspiring words, and for officially opening our seminar. Thank you, sir. And secondly, we also extend our sincere thanks to our today's guest of honor, Sri MSM Murthy, Vice President, VSM Group of Institution, Ramachandrapuram, for gracing us with your presence. Thank you, sir. And next, we are also extend our sincere thanks to Professor J. Hemalata, Madam, Department of Physics, NIT, Tiruchirappalli. For your words have set a wonderful tone for the seminar and will surely guide us throughout the coming days. Thank you, Madam. And we are also deeply appreciative of our esteemed speakers and panelists, Dr. Bipin Kumar Gupta, Senior Principal Scientist, CSR, NPL, New Delhi, and Dr. Sudhir Kumar Vempati, Professor and Chairman, Center for High Energy Physics, Indian Institute of Science, Bangalore, and Professor P. Vishnu Prashant, Mohan Babu University, Tirupati, and Dr. K. Naveen Kumar, Research Professor, School of Medical Engineering, Engam University, South Korea, and Dr. A. Bhargav, Research Professor, School of Medicine, Engam University, South Korea, who will be sharing their knowledge and insight over the course of the seminar. Your participation is crucially to the success of this event. Thank you, Madam and Sirs. A big thanks to you, our sponsors and partners, for their generous support. Your contribution have been instrumental in making this seminar possible. And to all our attendees, thanking you for joining us and for your enthusiasm. Your presence here today is a testament to the importance of the topic we will be discussing. And finally, I would like to acknowledge the hard work of the organizing committee and Department of Physics and Chemistry. Your decision and efforts have made this inaugural function a success. We look forward to a fruitful seminar and hope find the sessions engaging and valuable. Thank you once again and enjoy the rest of the seminar. Thank you.
Thank you, friends. Once again, I'm very much thankful to the collaborators, sponsors, Kalyani Chaudhary Garu, Ganesh Garu, Chakravarti Garu, Srinivas Ranga Garu, and all others. Okay, and also ONGC has sponsored us 50,000. They are going to give. Okay, so I am very much thankful, and also thankful to the esteemed speakers all the way they came, and I am thankful on behalf of my institution. Thank you, thanks once again, and I request all of you to please have a small tea at the ground floor. Then we'll come back to our sessions. Our first session will start within 10 minutes. You take 10 minutes break, and I request all the guests here, and all the participants, students, to have a small refreshment and tea, and come back quickly within 10 minutes. Thank you very much.
Kunandra, పడిపోతుంది. రాంబాబు గారు నమస్తే సార్, బాగున్నారా? వచ్చారా? స్టార్ట్ అయిపోతుంది సెషన్. రాంబాబు గారు మీరు వెళ్ళిపోతారు, కొంచెం టైం లేదు, సెషన్ స్టార్ట్ అయిపోతుంది. ఓకే. ఓకే, తప్పకుండా టీ తాగి తీసుకోండి. నేను టీనా
మేడం టీ తీసుకోండి అందరూ ప్లీజ్. వచ్చేద్దాం వాళ్ళు తీసుకొచ్చేస్తాం. మళ్ళీ వచ్చేద్దాం సెషన్ స్టార్ట్ చేసేయండి. బిపిన్ సార్ తీసుకున్నారు. బిపిన్ నవీన్ తీసుకెళ్ళాం. ఇద్దరు తీసుకున్నారా? సౌత్ కొరియా ఇద్దరు తీసుకున్నారా? తీసుకోలేదా? అంటే లోపల ఈ మెసేజ్ కలర్షిప్ చేయాలండి. అది మళ్ళీ వెనక పంపిస్తాను. మీరు అయినా కాపీ తీసుకోండి, నాకు కూర్చోండి ఇస్తాను. ఎందుకంటే తీసుకోండి మేడం. ఈ ల్యాప్టాప్ వరే కొనా ల్యాప్టాప్ పడిపోతుందా? చాలా టెన్షన్ ఉంది, అది పక్కన పెట్టి ఓకే.
ఫోటో గురించి
కొంత ధ్యానం రాదు. అయిపోయింది అదే వాట్సాప్ లైవ్
కొంతమందికి బ్యాగ్ ఇవ్వడం పల్ల పల్ల దీనికి చెప్పండి. బాగుంది ఫ్లవర్స్. ఈ వైట్ షర్ట్ ఉందని వాడేసి లేదా అలానే ఉంచినా పర్లేదు. రెడీ గారు కూర్చోండి మీరు. అదే అదే కూర్చోండి. ఇలా అక్కడే పెట్టి. ఇది మొహం జిడ్డుగా ఉంది, మనం వేసుకున్నా కానీ ఈ లైటింగ్ లో వస్తుంది. ఆయన వేస్తావా? ఆయన వేసుకుని మళ్ళీ మనం వాడకూడదురా. అందుకే ఎప్పుడైనా శంకర్ దాదా ఎప్పుడు బిఎస్ అన్నట్టు సుగ్నా చికెన్ లో వాడండి, మీరు కూడా లాగుతారు. ఇదిగో ఈ రా మరి.
పర్లేదు సార్.
బాబు రిషి ఏంటి టీ స్నాక్స్ ఏనా ఓన్లీ ఇంకేమైనా ఉన్నాయి అందులో? బిస్కెట్స్
కాదు సార్,
ఏంటి మరి?
ఒక కాజానే ఒక బూందీ.
మరి ఒక రెండు చేస్తావా నాకు రెడ్డి గారికి?
అలాగే
పైన ఉన్నారు. నీ పని అయిపోయిన తర్వాత అదే రెడ్డి గారు వెళ్ళొద్దామా? కాఫీ కట్టిగా మన రాజుగారు పట్టిన నేను ఎలా రెడ్డి బాబు ఇంకోటి అలానే 3 టీ కూడా. వాటర్ ఇంకా ఎన్న పని
చెప్పగారు మరి
కావాలంటే
హలో చెప్పా
మనలో ఉన్న ప్రాబ్లం ఏంటంటే ఆఫ్ అందుకని ఆఫ్ ని ఫుల్ చేస్తారు. అప్పుడు
కాబట్టి
కానీ భలే ఉంది. తాగిరా మీరు కూడా తాగిరండి టీలు. మరి కలిసి ఆ బాగాను అలా కదా ఇక తిన్నప్పుడు ఇదో ఈ పనులు ఎప్పుడు అయ్యే వేసుకున్నా వేసుకుంది. ఆల్రెడీ ఉన్నాయి 2 ఇచ్చాను రా.
చెప్పక్క
2 టాప్ ఇచ్చే మరి
నాకేమంటే
ఎవరు చెప్పారు?
సెమినార్లో లైవ్ జరుగుతుంది అదే ఇటక
తీసుకుని అరే నాన్న ఆ మొక్కలన్నీ అక్కడ పెట్టండి అమ్మా వరుసగా. ఇప్పుడు అసలు
నీకోసం సుహాసిన తడివేసుకుంటాం దాని నుంచి నుంచి వెళ్ళు
ఇంకోటి ఆ బ్యాచ్ బాగుంది బ్యాచ్ కన్నా కానీ ఎవరు పిలిచి ఎవరికి కలిసి కాకుండా తినద్దు అప్పుడు చెప్తున్నా కానీ ఈ ప్లాస్టిక్ అంతా డేంజర్ మనం పక్కన వెళ్తే మనం పక్కన అప్పుడు చెప్పలేదు మళ్ళీ
ఈ బెంచ్ సెంటర్లో పోయింది సెంటర్ లోకి కార్పెట్ అదే ఆ చెట్లు తీసేది అవతల మొక్కలు ఉన్నాయి కదా మొక్కలన్నీ అవతల పెట్టండి అదే
ఈ కంప్యూటర్ పెట్టావు ఎక్కడ ఎక్కడ వెనక మా ల్యాబ్ దీని పక్కన ఒక తాళం వేసింటే బయట పెట్టు
మేడం గుడ్ మార్నింగ్ ఉన్నారు ఇప్పుడు మేడం
ఇప్పుడే
స్వీట్ తీసుకోండి చిన్నది
సెమినార్ హాల్లో బాగుంది కానీ బయట బాగాలేదు కదా స్నాక్ ఐటమ్స్ రోజు తాగే కదా కొత్త
లేదు ఇలాంటి అవకాశం నేనే ఇస్తాను
తెలుసు కదా నీకు తెలుసు
అవును విజయవాడ నుంచి వచ్చారు సార్ ఒక ఆయన శ్రీనివాస్ సార్ గుంటూరు అండి కంప్యూటర్స్ సుందర్ గారు మన ఇక్కడ మాచర్ల నుంచి లోకల్ కాలేజ్ సార్ కాంట్రాక్ట్ ఫస్ట్ నుంచి గవర్నమెంట్ అంటే మీరు దత్తపుత్రులు కాదని
మేడం మీ సబ్జెక్ట్
మేడం కాదు ఒక పని చేయండి ఫస్ట్
ఈ ఫీల్డ్ లో పెద్ద గిరి కావాలి ఈ ఫీల్డ్ లో వచ్చిన తర్వాత
మైక్ ఫాస్ట్ గా వైర్లెస్ రా
మేడం పరిచయం కాకపోతే అంటే పరిచయం అయితే ఎవరిని వదిలేడు ప్రతి ఒక్కరు వాడేస్తాడు ఓకే చెప్పరా అంటే పెద్దపడి ఉంటారు
తీసాము ఏదైనా చెప్తూ ఉంటుంది
ఇలా ఉన్నాడు గుడ్ మార్నింగ్ స్టూడెంట్స్ గుడ్ మార్నింగ్ గుడ్ మార్నింగ్
మూమెంట్ ఉంటాం
ఇది బాగుంది అది ఇలా చేస్తారు Any topic, like continue. రండి 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 అదే కదా శ్రీకాంత్ చాలు ఫస్ట్ ఇక్కడ
హలో పీజీ అంజలి ప్రిన్సిపల్ గారు ఉన్నారు. ఎవరండి స్టేట్ ప్రెసిడెంట్ ఎవరు? మైక్ వైపు అనౌన్స్ మైక్ వైపు
Yes, sir. Okay.
రండి రండి కరెక్ట్గా మీరు అదే ప్లేస్ అలా వచ్చండి మీకు ఏసీ ఉంది
మేడం
Batteries also kind of hydrogen.
The first session, invited speaker, Professor Jawaharlal Hemalata ma'am, Department of Physics, National Institute of Technology, Tiruchirappalli. Please come on to the
Good morning, everybody. Welcome back to the session. Sir, shall I? Chairman, sir. Today, I am going to speak about multifunctional nanomaterials and their potential applications. Outline of this presentation is given here. I'm going to give some introduction about functional and multifunctional materials. Then I'm going to give potential applications, highlighting the sensor and energy storage applications which we do in our lab. We are working on magnetoelectric polymer nanocomposites for sensors and some kind of nanogenerators. And another team in my group is working on nanofluids also. So some interesting applications of those materials we will see today. Then if time permits, I will speak about ongoing research and then finally with intelligent biomaterials. Then functional materials. Materials which can sense and respond to the stimulus are called functional materials. You see, if for fun's sake, if we assume our functional material as an emoji, you just stimulate it. You give some external stimulus to that emoji, what happens? First of all, it has to sense. Your material has to sense the stimulus, and then if it is intelligent enough, it has to respond. Such a material we call as functional material. It can come under the type of active smart materials. And this sensing means these materials, they identify the change of any external parameter. That is what we mean by sensing in the scientific terms. And they have to respond means by the change of physical properties in a specific manner and converts the change into another form as another output. So this output can be a change in the shape, stiffness, resistance, strain, viscosity, or any other way. So something that is the stimulus has to be sensed and responded in some other way. Whichever material can do this, we call it as a functional material. And the external stimulus can be of any form like this. It can be pressure, temperature, magnetic field, electric field, various changes, even chemical changes, change in pH, nuclear radiations, anything of that kind. So such materials are functional materials. There are plenty of functional materials we already have. So I have tabulated the functional materials and the various stimuli and the response of these materials. If any material responds to electric field or current, it responds as an optical output, then those materials can come under these categories of electrochromic material, electroluminescent materials, electro-optic materials. They have subtle difference in their responses. Electrochromic material, when subjected to light, when subjected to electric field, it emits light. It changes its color actually. The change in color happens. This electroluminescent materials, upon electric field, they emit light. Electro-optic materials, they change their optical parameters like refractive index or any polarization changes. Some parameters, optical parameters change, so they have subtle differences in their performance. Similarly, thermoelectric materials, they respond to electricity and they respond to the heat and they give electrical outputs. And inverse piezoelectric materials, they respond to electric signals and they respond in a way of changing in their strength and mechanical properties. Electrostrictive materials and ER fluids. ER fluids, they respond in rheological properties. Upon electric field, they just change their viscosity. The particles inside the material, they just align themselves in the forms of strands and it reflects in the form of change in viscosity. So mechanical changes they give. Magneto-optic materials, when you apply external magnetic field, then some optical characteristics, mainly their polarization, angle, axis, these things change. So magneto-optic materials, MR fluids, similar to ER fluids, they change their rheological properties, especially the viscosity when magnetic field is applied. Then magnetostrictive materials, this is another functional material which responds to AC magnetic field, which changes its dimension. So mechanical output. There are plenty of such materials. Photoconductors, photochromic materials, thermoluminescent materials, thermochromic, shape memory materials are another interesting functional materials which can it's a shape memory. It can memorize the shape under certain conditions. When the temperature is above the characteristic temperature, and when you apply some mechanical force to those material, the material it remembers the shape. And whenever the temperature is kept below that characteristic temperature, then it goes back to its original. So recovery of the shape, memorizing the shape, recovery of the shape, it's an intelligent process going on in shape memory materials. And piezoelectric material, that there is inverse in piezoelectric materials. Accordingly, the mechanical electrical stimulus and response interchange. then magnetostrictive, mechanochromic. These are many functional materials. And multifunctional materials, they have all these applications. I will come to the introduction in the next slide. But multifunctional materials, they have applications in biomedical field, communication, space, environment, defense, and nanotechnology research, and many other fields. Okay. Okay, let me just introduce the multifunctional material and then go back. In the previous slide, I just listed out many functional materials, right? Next, we come to multifunctional materials. From the name itself, you can understand it is a combination of different functional properties inside the material. So first of all, functional material should respond to some external stimulus. Now, if the same material is going to have multiple functionalities, then you just think of its performance. It will respond to various stimuli. You can make it work intelligent way through different. You are getting more degrees of freedom to work with the material. You have more control on the material, right? So you can have any intelligent combination of different properties. The same material can be magnetic and transparent, can be conducting, can be transparent, can be magnetic, can be catalytic, can be magnetic at the same time it possesses high optical properties. Magnetic and shape memory. You just imagine shape memory. Shape memory alloys and all, they are used for that inserting that stent thing, that angiography and the stent. So they are using shape memory, and if it can be controlled through an external magnetic field, how good it will be. So this magnetic and shape memory, electrical shape memory, all these things make the material multifunctional. They possess multiple functionality, they become active, smart materials. Yes. Now the examples for smart material, polymer nanocomposites, where we are working in, there are different kinds of polymer nanocomposites. Basically, for the students, I say polymers are very good materials having wonderful mechanical properties. But when it comes to the functionality, polymers are not at all functional. They have wonderful mechanical properties, but not functional. If you apply electric field, they won't do anything. If you apply magnetic field, they won't do anything by nature. But if at all you want to combine some functional property to that, you have to do some modification, right? You can make them functional. You can make them multifunctional. That is what we do in our lab. By making some polymer-based composites, we create some multifunctional polymer composites. So light-emitting polymers are possible. These are all the general introduction about these. Light-emitting polymers. Polymers, as of now, by nature, they are not light-emitting. Can you reach you there? Can I? You need some explanation? Okay. So OLED, organic LED and polymer LED, these are all the current topics with the polymers, making the polymers functional. Then you can make the polymer conducting. By nature, very few polymers are conducting. That too, they are not electron-based conduction, it will be ionic conduction. We have very limited number of conducting polymers, but with composites, by introducing appropriate polymers, appropriate manner, you can make them highly conducting. So you can make shape memory polymers, chromic polymers. Chromic can be electrochromic, thermochromic, photochromic, whatever way they are being stimulated. Through electricity or heat or through light, they can change their colors. So you see, this is a polymer film, a flexible polymer film producing light as PLED. And you know this photosensitive glasses and all you know. Based on the light variation, it changes its color in the cooling glass. See, based on the heat, changes color. So these are some of the examples for these smart materials. Now what you see on the screen is a beautiful girl wearing a pretty dress and dancing, right? You see the dress, same girl, same dress, but what you see? The change in color, right? Somewhere inside she is hiding some button or something through which she is activating the electrical signals. The electrical signals, since this is an electrochromic material, it changes its color, makes it more and more attractive as time passes, right? So electrochromic material, again thermochromic material, these are all commonly, you know everything about these chromic materials, right? So this kind of materials we want to do. We don't present it in such a way, but we do it for some research applications. So electrorheological fluids, already I just highlighted what it is. Electrorheological fluids, they mostly are suspensions or colloids, where very small particles are suspended stably in a liquid under electric field. When you apply electric field, the particles, they align themselves in the direction of electric field. It forms some kind of a strain change. The strands are created that changes the viscosity of the liquid. So that is the response. The rheological changes take place. Similar kind of phenomenon you expect from magnetic field in MR fluids. They respond to magnetic field. When there is no field, randomly distributed particles, but when magnetic field is applied, you see all the particles align themselves in the direction of magnetic field. So this creates change in viscosity. So you control viscosity. Whenever you want, you can make it a little less viscous or high viscous based on the application of magnetic field. So you see, when there is no electric field, this is a ER liquid demonstration is shown. When no electric field, you see it behaves like a liquid. When you apply electric field, its viscosity is high, so it becomes a solid like, and there is no flow in that. So it is blocked, the flow is blocked. So it's a flow of a liquid which flows, but the flow is controlled by electric field. In MR fluid, the same can be done by magnetic field. This is also an example for ER only, ER fluid, and kind of electrodes shown here. Just immerse the electrode inside ER fluid and take it away. That liquid will drift. It still retains its flow behavior like a liquid. But when you apply electric field, turn on the knob and apply electric field, see what happens to ER fluid. It doesn't flow. It just connects the electrode and behaves like a solid. Its viscosity has become increased. So these are some interesting functional materials, and I introduced the multifunctional material which can combine any of these functional properties. It can have multifunctional properties. My group's interest is on these two. Magnetoelectric multiferroic materials. I think you know about multiferroic materials. Multiferroic materials, they combine multiple ferroic properties. There are naturally three ferroic properties available: ferroelectricity, ferromagnetism, ferroelasticity, right? Here, this magnetoelectric materials, they combine ferromagnetism and ferroelectricity. Can we have these two properties in the same material? It's really a challenge to have these two properties because the mechanisms of these two materials, they contradict with each other. So we cannot have a multiferroic property, magnetoelectric multiferroic property in a single phase material simultaneously. So we go for nanocomposites where we can induce this magnetoelectricity in that material. And another interest is on ferrofluids. I think you heard of ferrofluids, nanofluids. They are smart fluids which combine the flow property as well as superparamagnetism. Have you heard of superparamagnetism? Yes, that we have at nanoscale with ferromagnetic materials, and these materials, they combine that superparamagnetism as well as flow behavior. We can say it behaves like a liquid magnet. It also combines ER and MR property, electrical rheology and magnetorheological properties. This is my lab in NIT, Advanced Materials Lab, and these are some of my students working with electrostreaming and some liquid characterization studies. Yes. Now, mainly under this topic of smart materials, I'm going to focus on these two polymer nanocomposites we make in our lab, mainly the films or mats with particle or fiber filler, and with these we want to look magnetoelectric multiferroic nature or GMR effect. Most of our multifunctional materials, they exhibit GMR or PMR effect. And smart nanofluids, we work with the nanofluids, magnetic nanofluids, which are nothing but ferrofluids, ionic liquids, and hybrid magnetic materials also, hybrid ferrofluids, both on aqueous or non-aqueous liquids. So these are the films we prepare, flexible, magnetoelectric multiferroic films for various applications, and water-based nanofluids. These are the ferrofluids. From this picture you can understand it behaves like a liquid magnet. Here there is no magnet. As such, the prepared material is kept in a vial. When you keep a magnet near it, you see how what happens? The magnetic fluid, it flows, right? It retains the magnetic, but you cannot expect this in ordinary rheological fluid with the other materials, right? If you keep in ordinary materials, sometimes you have magnetic inks. In the ink, if you keep magnetic poles, the ink it will separate. The particles alone will go, leaving behind the liquid. But here, the liquid as whole, it moves, right? The flow property of the liquid retains. At the same time, there is superparamagnetic nature. Yes. When we prepare this polymer nanocomposites, we use polymers, blends, and copolymers. And in the place of nanofillers, we use various things. Finally, we get this polymer nanocomposite. In place of nanofillers, we work with complex metal oxides, small-sized, nano-sized complex metal oxides, and fibers and rods. This is what we are using in our lab, and most often we use with these polymers: polyvinyl alcohol, TANI, PVDF, PVDF HFP. It's a copolymer of PVDF. These polymer-based materials we prepare, and the final product, it will be in the form of films or mats, nanofibers, core shell nanofibers, core and shell. It will be like single axial fiber.